So we are left off at conversion factor between two different systems. So let's say I want to find the conversion between 1 Newton and 1 dyne. So according to what we have learned so far, let 1 Newton be x dyne, be a variable x. So the dimensions of force is, let us say, ma, so that it gives us m1, l0, t0, and a is l1, t minus 2, and what is it, m0. So force is, let's say, what, m, l, 0 plus 1, t minus 2, m1. So that gives us L1, T minus 2, and M1. So let the force, so no matter what system it is, the dimensions of force will always be the same, right? So force, no matter what system it is, CGS, FPS, or MKS, we have force is equal to L1, 1, T1, 1, T minus 2, and M1, 1, and let this be equal to let this be equal to x times L2, that is in centimeter, L2 1, T2 minus 2, and M1 1. Stupid thing. Alright, so this is it, and so x will be L1 1, M1 1, T1 minus 2 upon L2 1, M2 1, T2 minus 2. Alright, because we had said that let 1 Newton, so let these be the dimensions, let these be the dimensions and newtons, and let these be the ones in dyne. So let 1 Newton be equal to x dyne. So this is x, and here it is. So now we have this thing where x will be equal to L1 L2 square. Alright, because of okay, no, this is 1, so they will have the same powers, they will inherit the powers. Alright, so this is L1 1 and M1 upon M2 1, and T1 upon T2 raised to the power minus 2. So in the SI system, LMT are represented as, so this is 100 centimeter upon 1 centimeter, because L2, these two ones are in CGS upon M1, which is 1000 gram upon 1 gram, and time remains the same, so it's 1 makes no difference. So here we have, let us write it again, we have 10 raised to 2 centimeter into 10 raised to 3 gram, which gives us x is equal to 10 raised to 5. So 1 Newton is 10 raised to 5 dyne. And that is the significance of dimensional analysis, and also to establish the relationship between related physical quantities. So let us say that the time period t of oscillation of a simple pendulum toing toing tung 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 is depends on the length t. Depends on the length t and acceleration due to gravity g. And so we are supposed to derive an equation between T, L, and G. So how will we do it? Let T equal to K length into gravity of time, where K is the constant of proportionality constant, and let T be equal to K Lx Gy. So let this be the relation between them, because we don't know how they relate to each other. If T is equal to L square G cube, or T is equal to root L into G cube, or how do they relate to each other? So what is the relation between them? So to find that, let us put the parts as variables x and y. Very simple. So now we know that an equation, the two sides of physical quantities, the dimensions are always the same. So the dimensions of our right hand side, we just have time. So it's L0, M0, T1. Now on the LHS, it has to have the same dimensions. So K is dimensionless. So it is Lx and okay, let's move on. So these are the dimensions of our left hand side. Now our right hand side, we have the dimensions of L, which is L1 M0 T0, and we have G, which is L1 M0 T raised to the power minus 2, because G is nothing but acceleration, and we've learned that this is the representation of dimensions of acceleration. So rewriting the equation, like LHS, which is equal to L1 M0 T0 raised to the power x, because Lx into L1 M0 T raised to the power minus 2 raised to the power y, according to our first two equations. So basically in the LHS we still have time, and the RHS we have, as per we have learned, we don't have enough space here, I'm sorry. Okay, Lx plus y into M0, which remains 0, and T is minus 2y. Alright, so we know by comparing the powers of L, M, T. So what we do is, in dimensional analysis, when we have two equations on two dimensions on two sides, and when we have variable on one side, let's say, consider this example we are using now, which is equal to Lx plus y M0 T minus 2y. So when we know that this is equal to this is equal to this, what we do is we equate its parts. So x plus y, the parts of L will be powers of L here. So wait, to make it more clear, the powers of L are same as powers of L. Alright, the powers of M are powers of M, and powers of T are powers of T, because they are the same thing, because we know that they are equal. Alright, so moving on. So we equate them. So we know that by equating the parts of each of them, so we know 0 is equal to x plus y, 1 is equal to minus 2y, and y is equal to minus half. So therefore y is equal to half, and x is equal to plus half. So substituting these values, we get t is equal to k into L raised to the power half Lx G y. So y x. So t is equal to k into L upon G is our equation. And so we know that k is 2 pi, so L upon G, that is our equation. So to find how equations are related, so this was dimensional analysis and its uses. Thanks for watching. Please like, please like or comment.